Time for another runtime comparison of BASIC09 and Color Basic. Same algorithm, same clock rate. This time we answer the question, given all the pennies, nickels, dimes, and quarters we need, how many different ways are there to make change for $1? Let's start with a version that appears in Stephen M. Pereira's article A Vintage Computer Benchmark, in Cocoa 123 Volume 40 No. 1. In it, nested loops iterate over the possible numbers of pennies, nickels, dimes, and quarters looking for the combinations that add up to $1. This time, by the end, both the Color Basic and BASIC09 versions will run so fast that a stopwatch just won't do. Humans don't react fast enough. Instead, we'll get the runtime using the timestamps on the starting and stopping frames of each run. Cocoa users are an observant bunch, so you've probably noticed that the code goes through pennies in increments of 5. $1 is 100 cents, and 100 is a multiple of 5. The denominations of all the coins other than pennies are multiples of 5 cents, so their values necessarily add up to a multiple of 5 cents. It is therefore ideal, bad math joke, to only check multiples of 5 pennies. If we iterated over 0, 1, 2, and onto 100 pennies, we'd take 5 times as long to no purpose, and nobody would sit through this whole video. Honest, this won't take as long as the Color Basic 8 Queens program did. Even if you do skip past the rest of this run, watch what happens afterwards. It gets much faster. You know, those extended warranty scam calls give the rest of us synthesized voices a bad name. There you have it. The color BASIC code runs in 4 minutes and 58 seconds, while the BASIC09 version runs in 22 seconds, about 13.5 times faster. Clearly, integer arithmetic and avoiding the runtime overhead color BASIC imposes makes quite a difference. Now, let's look at the code again. First, the loop bounds are all fixed. We know that the check in the innermost loop will be done 24,255 times, 21 times 21 times 11 times 5. That innermost check does 3 multiplies, 3 adds, and a compare. Second, the program is doing a lot of needless work. Consider the last time through the pennies loop. 100 pennies. Sure enough, with 0 nickels, 0 dimes, and 0 quarters, that adds up to $1. But why go through the other 1,154 combinations of nickels, dimes, and quarters? Adding more money to $1 won't give you $1. Clearly, there's no point in adding coins once you reach or exceed $1. The easiest way to do that is to iterate over the values of a given number of nickels, dimes, and quarters. Then, instead of multiplying every time through the inner loop, divide to turn the values into the corresponding numbers of coins. Division is more expensive, but here it only happens when the code finds a solution. Let's see what happens with that change. Not shabby. The color BASIC version runs in a hair under a minute and 12 seconds, the BASIC09 version in about 6 seconds, 12 times faster. It turns out that the innermost loop test only happens 1,586 times instead of the 24,255 times in the first version. But there is another thing we can do. Why are pennies the outermost loop? Think about it. If we've chosen nickels, dimes, and quarters whose total value in cents is some number v less than or equal to 100, we immediately know that adding 100 minus v pennies gives us $1. We don't need a pennies loop at all. Let's see what this does. That's respectable. Not quite 37 seconds for color BASIC, a little over 4 seconds for BASIC09, slightly over 9 times faster. The innermost loop necessarily runs as many times as there are solutions. But then, our original question was just how many different ways there are to make change for $1, not how many there are and what they are. At this point, we may well be IO bound, spending most of our time printing out the various combinations of coins. If we aren't doing that, we don't have to figure out how many of each coin denomination corresponds to the solution, throwing out the expensive divides and the penny calculation as well. Let's try it. Definitely IO-bound for both languages. The Color Basic version takes about 2.2 seconds and the BASIC09 version about 0.12 seconds, about 18 times faster. Is this as fast as it gets? In general, no. As you increase the amount to make change for, this method has to do a lot of work. The best method in general uses dynamic programming, a fancy term for using the solution for smaller values to calculate the solution for larger values, but this is already longer than the 8 Queens video, so it can wait until later. It would be shorter without the Color Basic runs, but that defeats the purpose.